Well, hello, everybody. Welcome. My name's Philip Brown. I've got a really cool problem right here. Hey, these problems right here, they can really make you feel bad. However, they're just puzzles. If you think of them like puzzles, it's just kind of fun, right? So we're going to do this in two parts. We've got these properties of exponents that are being used in a very clever way to make this kind of a tricky question. We're going to call it Algebra Gone Mad. So in the first part, we're going to explore this problem and problems like it. And you can check the description for the timestamps. You can skip to the solution if you like. I would like you to share with me what you think it is and how it's going in the comments. Here's the order in which we're going to do this video, right? We're going to talk about the properties of exponents that are really at play, things you got to be careful of, right? And if you feel pretty confident you don't need that, you can just go ahead and skip to this part because I'm going to go through the solution. And while we do that, we're going to talk about how we can have some confidence that we're on the right path, because nobody wants to do a whole bunch of work and end up with some answer that's really bad. And at the end, I'm going to share with you two problems and a challenge problem. The challenge problem's going to lead into the second part of this little short series, right? By the time we're all said and done, man, you're going to be a math boss. I don't know if this is a good book right here. I just did a Google search for math boss meme. This pug right here came up, and I love the cover. I'm going to buy the book just because of the cover. I'll let you know if it's any good or not. I mean, man, it is fantastic. The cover is anyway. So let's go ahead and get to it, shall we? So I'm going to start off by talking about what properties are really at play here that get a little confusing. So if you don't need that and you think you want to just jump to the answer, you can do that. Just go ahead and use the timestamps in the description. So without further ado, let's get into it right here. So what we've got to do is we've got to take this thing here and we've got to manipulate it to look like this. And that's kind of tricky because we have some restraints or constraints on what it is we have to do. We need to make the structure of this expression on the left look like this expression on the right. We have to find the coefficient of a and this thing that's being added in the numerator, and we're going to have a single fraction. And it's x to the sixth, which is not what this is right here. So, man, before you dive in, let's take a look. We're going to have some negative exponents to deal with. Those can be tricky. You got to be very careful. We have a minus sign too. That's also tricky. It's really easy to confuse those. Of course, we have the product rule. So if you multiply things with the same base, you have the exponents. And there's also the power rule. So if you raise a power to the power, you're going to distribute, right? So got all that going on. So let's be really careful, though. You have to make sure that if you see a number like this, just a plain old 2 or a plain old 4 or whatever, it has an exponent of 1. Also, this minus sign is not a negative base, so it has nothing to do with the negative exponent rule. So all those things in mind, let's keep those things in the forefront of our mind, I should say, and let's go ahead and dive in. So power raised to a power, we multiply, so we're going to do that here and here, and we're going to get 4x to the negative 6th over there on the right, and in the denominator on the left, we're going to get 2 to the negative 4x to the negative 8. Now, the reason that the x here goes to the denominator is because negative exponents mean division, and the way you divide is you multiply by the reciprocal, so it gets flipped over. The problem is the 4 has an exponent of 1. It's positive 1. It's a negative 4, but an exponent of positive 1, so it's going to stay in the numerator just like that. Now, over here on the left, see, we had a numerator, 2x to the 4th, that was a positive exponent, so it's going to stay in the numerator, and this part in the denominator moves up to the top. You multiply by the reciprocal, so that's what we get. Now, let's go ahead and take the next step, and before we really start diving into manipulating this expression, let's see if we're on the right track. So the first thing I noticed to see if we're on the right track is this x to the power of 6 in the denominator. That makes me feel pretty good. I do know that we need to make this a single fraction like we have over here on the right, and we're looking for the coefficient of x and the b. The b might be negative 4. We're going to find out. One little problem I see is x to the 18th, but over here I have an exponent of 4 for x and an exponent of 8 for the x. Not quite 18, that's 12. So let's go ahead and start to simplify this, and then we'll start to address getting a common denominator so we can write this as a single fraction. So these bases are the same. The 2's are the same, of course. So 1 and 4 makes 5, and then the x's have, of course, the same base, right? So 4 and 8 is 12. We'll go ahead and plug that back in right there, and here's what we've got. Now, let's go ahead and multiply both the top and bottom, the numerator and denominator, by x to the power of 6, right, to get a common denominator. When we multiply all of these things together right here, the x's have the same base, so we can add those exponents, and look at that, we have an 18. So we're looking for, and in the denominator, x to the 6th. So that's pretty cool. And we can just put that together as one fraction since they have the same denominator. And now we can see 2 to the 5th is a. Negative 4 is b. That's pretty cool. So 2 to the 5th, that's the coefficient of x. So that's what a is. And the negative 4, that's the thing being subtracted over there. So that's pretty cool. Hey, did you get it right? What do you think about that problem? If you didn't try it and you just walk through, why don't you try one of the two problems I'm going to share with you right here? These two practice problems, I've got them right here. In both situations, you're going to solve. You have to figure out what is the value of a. So you have an expression on the left that you need to manipulate to look like the expression on the right of the equal sign. Same thing for the bottom one, both the same. You're going to find the value of a. Try them out. Leave me comments on how you think you did, and I'd like to hear from you. Last thing. I promised you a challenge problem. This challenge problem is actually going to get us started on the second video. It's right here. It's still just exponents, but it's got a little bit of a twist. It's a different flavor, a little bit more difficult. So why don't you give that a shot, see how it goes, right? Let me know. Hey, if you liked this video and you like this content, do what all the cool kids are doing. Like, subscribe, share. Check out my website. I'll leave links for all that kind of stuff in the description. I've got a Substack where I have a weekly challenge problem just for fun. I use it in my classroom. I'm surprised how many students do it. More students are doing it every single week. So I post that in my Substack, give you access so you can download all that stuff and use it yourself if you're a math teacher. Hey, in the meantime, I hope you really enjoyed this problem. I know I did. I hope to see you soon in the next one, and I will talk to you later.